Hello, welcome. Let's try to solve another Leetcode problem. 2204, distance to a cycle in undirected graph. So normally the cycle problem, it has a directed graph or undirected graph. But for this problem, it's going to be an undirected graph. And the number of nodes is going to be from 0 to n minus 1. And the number of edges is going to be equal to n according to the question. So from here, the number of edges equal to n, and this n going to be 7. And definitely inside there going to be exactly one cycle. And we are also giving a 2D array of edges. So the edges I equal to node I1, not 1i, and node 2i denotes there is a bidirectional edge connecting node 1 to node 2. So the meaning is that, for example, 1 connected to 2, 2 connected to 4, it is straightforward. So the distance between any two nodes is defined as the minimum number of edges that are needed to go from A to B. So for example, the distance from 0 to 1 is going to be 1. But as this is going to be a cycle from 1 to 4 and 3, so this means we are going to calculate all the nodes distance to the cycle. So for example, 0 nodes distance to the cycle is going to be 1, and because 1, 2, 3, and 4 is a cycle, so it's going to be 0 because the distance to itself is 0. And for this 5, it's going to be 1, and 6 is going to be 2. So exactly how can we solve such kind of problem? Because our final answer, we just need to calculate the distance. So first of all, we need to detect the cycle. We need to find which one cycle it is, because we are giving exactly one cycle. And we can use the topological sort to find the cycle, because this is basically a graph problem, but actually it is a tree cycle problem. We should know that there's an undirected graph or directed graph. We can use the topological sort to solve it. Because topological sort is not only used to solve the directed graph problem, but it can also be used to solve undirected graph problem. We only need to change the template code a little bit, and then it should work. So where is our starting point? So we're going to start from the nodes which has an integrity of 1. Because this is an undirected graph, so this means that the integrity is going to be at least 1, because 0 to 1, 1 to 0, so the integrity for this 0 node is going to be 1, and the integrity for this node 6 is going to be 1. So we're going to start from this node 0 and 6, and we're going to start the topological sort. So after this 6, we're going to get the 5, and after this 0, we're going to go to 1. But because while we are checking the topological sort, we're going to check the integrity. So if the integrity is 1, it is okay. We just put it inside the queue, and we're going to pop it out for the topological sort. But for this 2, even we pop out this 5, and we disconnect this 0, we disconnect this node 5. So the node for 1 and 2, the integrity is going to become 2. Because currently, before it is 3, now after disconnected, it's going to be 2, and for this node 1 going to become 2. So this means for example 1, 2, 3, 4, all the integers for those 4 nodes are going to become 2. So this means those 4 nodes are going to become a cycle, because all others we just pop out from the queue, and the integrity for all those nodes gonna for all those nodes are going to become 1. Before this node 5, the integrity is 2. But here, after we disconnect this 6, the integrity is going to become 1. And after we disconnect from 2 to 5, so the integrity for this node 2 is going to become 2. And also for this node 1, node 3, and node 4, so the integrity is going to always become 2. So if we can find this kind of a cycle, so the next step is that we can directly use a multi-source BFS. So the multi-source BFS idea is that we're going to start from all those nodes like 1, 2, 3, and 4, and we're going to start the BFS, and from the BFS we can get the final result. Because definitely from this node 4 there may be some other node, we don't know. From this node 3 there may be some other node, so we're going to start from 1, 2, 3, 4 at the same time. So for the BFS, for 1, 2, 3, 4, it's going to become 0, but when it goes to this 0, so the distance is going to become 1. So the distance while it goes to 5, the distance is going to become 1. While it goes to 6, the distance is going to become 2. Maybe there's another node 7, so the distance is going to become 3. So this is why finally we're going to use multi-source BFS to solve the problem. Now let's just start coding. So as I said, it's gonna prepare the integrate. It's gonna be 0 times the number of nodes, this n, and I'm gonna prepare a graph. It's gonna be adjacency list. So it's gonna be a default dict. Inside it's gonna be a list. Yeah. Now what are we gonna do? We're gonna check all the edges. So for UV inside the edges, and we're gonna prepare the graph. So as it is an undirected graph, so GU gonna append this way, and similarly GV gonna append the U. And next, so the integrate for this U gonna plus equal to 1, and similarly the integrate V gonna plus equal to 1. So this is only the preparation. Now we're gonna start the topological sort, and we're gonna prepare a Q. So inside is gonna I for I and integrate in enumerate. Let me just enumerate the integrate array, and I will have a check. So if this degree gonna become 1, yeah. If it is a directed graph, the degree gonna become 0. But this is gonna be an undirected graph. So we need to find such node such as 0 and 6. So this is why we're gonna use this kind of formula. Basically, we can check the node with 0 and 6, and we're gonna put it inside of the queue, and we're gonna start the topological sort. Now we can start it. So while Q, we're gonna pop it out as a node from the left side. So we're gonna check the neighbor, and we should know that while we are using the topological sort, we should not prepare the weighted set, because topological sort BFS is different from the normal BFS, because this integrate is actually our weighted set. That is why we don't need to prepare the weighted set for the topological sort. Let's just check the neighbor. So for neighbor in G with this node, and we can start to check the integrate with this neighbor, gonna mount as equal to 1, and we're gonna check the integrate with this neighbor, and if it is equal to 1, basically we need to put it inside the queue. So we're gonna append this neighbor. So currently what did we do is that after such kind of a calculation, we disconnect this 0 node, 5 node, and 6 node, and what left behind is 1, 2, 3, and 4. And for all those 4 nodes, the integrate gonna become 2. So we're gonna take it out and put it inside the weighted set and put it inside a queue, and we're gonna start another multi-source BFS to solve the problem. Now let's just start the multi-source BFS. So let me put it here. So this is also very famous, so we're gonna call it multi-source and BFS. So we're gonna start it. So we're gonna prepare a queue. Maybe I use the same name. I think it should be okay. Yeah, because currently I will not use this queue anymore, so I just prepare another queue. It's gonna be the queue, and inside, as I need to take the node, and I need to also use the distance. So it's gonna be from the beginning, the distance is gonna be 0, because inside of the cycle, the distance is definitely gonna be 0. So I0. So for I, let me use. Yeah, for ID in enumerate the integrate. So if the degree, if the integrate is equal to 2, yeah. So for such kind of calculation, actually I put all the node inside of this queue, and let me just copy it. Yeah, maybe. Yeah, let me prepare a weighted set. So it's gonna be a set. And inside it's gonna be the same node. Let me just copy those lines because it's gonna be the same. Yeah, so inside here it's gonna be another node. Now let me just maybe prepare print out something to check. Otherwise, it is too much coding. I'm going to prepare a final result. It's gonna be 0 times n. Yeah, let me just check what is this Q. Yeah, because if we know what is the Q, basically we know what is the weighted set. Let's just check what is this Q. There's something wrong. Yeah, so as you can see, inside the Q, inside this Q, what we put it inside of our multi-source BFS, it is node 1, 2, 3, and 4. This is what we need because this is the cycle, and we're gonna start from the cycle to go through the BFS to get the final answer. Now let's just start another BFS. So while q, we're going to pop out the node and the distance. It's going to be equal to q dot pop from the left side. So we're going to check the neighbor. So for neighbor in G with this node. But here we needed to use the weighted set because this is multi-source. So if neighbor not inside the weighted set, so the weighted set is gonna add this neighbor. Yeah, currently I think we've already finished everything, but we didn't record the final result. So the final result is gonna be, yeah, we didn't put anything inside of the queue, and we need to put something inside of the queue as well. So it's gonna be the neighbor, and the distance is gonna plus 1. So for example, if we pop out this 2, so the distance from 2 to 5 is gonna become 1. So this is why we're gonna append a distance plus 1 inside of the queue. At the same time, we can record the final result. So the final result for this neighbor gonna equal to distance plus 1. And finally, we just need to return the final result. Let me just run it to check. As you can see, it works. Let me just submit it to prove. Yeah, as you can see, it passed all testing cases, and I think the speed is okay, because basically we just go through a topological sort and go through a BFS, and the time complexity gonna be OE plus V. E gonna be the number of edges, and V gonna be the number of vertices. But as the number of edges is gonna equal to the number of vertices, so the time complexity gonna become ON. That is why it is so fast. So as we can also check the constraints. So the graph is connected, the graph has exactly one cycle, and there's at most one edge between any pair of the vertices. So all those kind of information, it is tell us this is going to be a tree cycle problem. The tree cycle, it is just a cycle with a branch tree structure. So this is going to be a tree cycle problem. Yeah, I think that's all for it. Thank you for watching. See you next time.